Okay, I am back to finish up the review of the practice test. So let's look at the linear programming problem here. So you're told that you're making piñatas, mini and regular. So I'm going to let x equal the number of mini piñatas, and I'll let y equal the number of regular piñatas. And before we do the other parts, it'll be helpful to make a table. So the first column will be whatever we're trying to build or make, which are piñatas. I'll put mini in the first row, regular in the second row, x and y. And if we look at all the data we're being given, we're being told about hours and cost and candy. So that means I need 3 more columns for hours, cost, and candy. And in black here, let's look at the minis. The minis require 2 hours, 100 pesos, and 100 candy. And then for the regulars, 3 hours, cost of 200 pesos, and 210 pieces of candy. Okay, so based off that, we could totally make our objective function constraints. So the objective is your goal. And what is the goal here? To maximize pieces of candy. So clearly I'm going to use that column. We can use capital C, or really any letter. Capital C will represent the total number of candy. And that's going to equal 100x plus 210y. Because again, if x is the number of mini piñatas, and there's 100 candies in each of the mini piñatas, 100x will be the total number of candies that come from the mini piñatas. Same reasoning we can use for the regular piñatas when we have 210y. For the constraints, you can't have a negative number of piñatas, so obviously these are 2 guaranteed constraints. And then we're obviously limited by hours as well as the cost. So for the hours is 150 hours, so we're going to use this column to make that constraint. And because you can't go over 150, we go less than or equal to. And also for the cost, you'll have 8,000 pesos to spend. So 100x plus 200y has to be under 8,000. Now when we graph, the best way to graph is to make intercepts, because the intercepts could represent a vertex that we'll have to use in our feasible region. So here you have 75, here you have 50, here you have 80, here you have 40. This should be easy. X-intercept when y is 0, y-intercept when x is 0. You solve for each case. When I graph this, here is 75, and here is 50. And 80 right there, and 40 right there. So we have that. And actually, you know what? I'm going to redraw that. I could do a lot better than that. All right. And then we'll use a different color for a bit of contrast. No, that's not enough contrast. There we go. They're kind of close together. Okay, that's a bit better. Not quite straight, but whatever. So the shaded region is going to be below the green and orange lines, but of course above the x-axis and y-axis, because x is greater than or equal to 0, y is greater than or equal to 0. And the corners, that should be easy to find. Here, 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 and here. So that will be part E. 0, 0 is one corner. One of the y-intercepts, 0, 40 is another. One of the x-intercepts, 750 is another. And then for the point of intersection, so you're going to have to solve for x and y from both of these inequalities here, or you can treat them like equations, I guess. You could do it by hand, by substitution or elimination, or if we go to the Wabbit, basically your calculator. Oh, and I just realized I don't have the program. Nope, I don't have the program there. So just believe me, if you use a program, the Solve 2EQ program, it's really easy to use, you will get 60-10. But you could also solve by hand too, by elimination or substitution, using 2x plus 3y equals 150 and 100x plus 200y equals 8,000. And then, of course, to figure out which combination gives you the most, if we plug in 0, 0, you get 0. If you plug in 0, 40, remember we're plugging back into our objective function. Plug in 0, 40, we get 8400. Plug it into 750, you should get 7500. And if you plug in the other one, you should get 8100. So clearly, the winning combination here is no mini, 40 regular, which produces 8400 candies. And this keeps us within our constraints, so we don't spend too much money, we don't use up too much labor, and we maximize the candy. So it's the most optimal situation. It's the best situation we can have. Okay, last problem. For this one, we want to write a system of inequalities for this graph only using linear and only using absolute value. So for part A, we're going to draw 4 lines, and I'm going to label them like you see here and here. So for the first line, it obviously has a slope of 4. Slope of 4, because you go up 4 over 1. A y-intercept of 4. And shading is below, so you're going to have that. For the second line, the slope is still 4, but now the y-intercept is negative 4, and the shading is above, so it's got to be greater than or equal to. For the third line, the slope is now negative 4, because you got to go down 4 over 1. Y-intercept is negative 4, and you got to shade below. And for the fourth one, you got to go up 4. Sorry, you're still going down 4 and over 1 for the fourth line. So it's negative 4x, but now the y-intercept is positive 4, and the shading is below. And I lied about number 3. It's supposed to be greater than or equal to. My apologies. It's been a long day. Anyway, so that's how you do it for linear inequalities. For absolute value, and actually let me erase all this stuff here just so it doesn't look so busy. So here's one absolute value, and another one will be right there. We'll call this absolute value 2. Call that absolute value 1. Actually, it's supposed to be red, whatever. So remember, absolute value is supposed to look like this. So the vertex is, for the red absolute value, is 0, negative 4. So you're just going to have absolute of x minus 4. And the slope, you have to go up 4 over 1 on each side. So you have that. And plus the shading is above. So it's greater than or equal to. For the green, for number 2, our vertex is 0, 4. So you still have 4 outside of x, but plus 4. Because remember h is 0, k is 4. And also it's going down 4 and then 1 on each side. So that's negative 4, and the shading is below it. So we got to say less than or equal to. So that completes the solution for the practice test. Thank you for your patience. I know it took me a while to get this together. And come by during office hours if you've got any questions. See you later. Bye.